I'd just like to say a couple of things about two common bases that are used in science, and then in the next video we'll go on to a third one. But first of all, let's talk about logs in base 10. So this is probably the most common one. This is normally written simply as log. So if you look at your calculator, then the button that says log, this is what it does, the logs in base 10. Okay, and this is the most commonly used one. So if you just hear log and no base, then it's going to be log in base 10. So what I'd like to do here is just give you an idea of kind of the scale of it by, I'm going to draw out, I'm going to have log in base 10 here on the bottom and normal numbers, if you like, on the top. Okay, so we're going to start here in the middle with 10 to the power 0, which we discussed is equal to 1. And so the log in base 10 of that is 0, because the exponent here is 0. Then if we move up, we've got 10 to the power 1, so the logarithm is 1, so that's equal to 10. So these numbers are all equivalent. So the log in base 10 of 10 to the power 1 is equal to 1. 10 to the power 2, or 100, the logarithm in base 10 of that is 2. 10 to the power 3, or 1000, the logarithm is 3, because the exponent here is 3. And if we go smaller, so 10 to the power minus 1, or 0.1, then the logarithm is minus 1. 10 to the power minus 2, 0.01, 1 over 100, 1 over 10 to the power 2, minus 2, and then 10 to the power minus 3, or 0.001, 1 over 1000, the logarithm is minus 3. So to go from minus 3 to plus 3 logarithms takes us from 0.001 to 1000. And I'd just like to contrast that with another really common logarithm, which is the logarithm in base 2, which we also use sometimes. It's useful for calculating things like bacterial growth, where the cells double in a certain time, or radioactive decay, things like that. Okay, so we're going to do just the same thing for the logarithm base 2. So if we have 2 to the power 0, that is equal to 1, we've discussed that, and the logarithm base 2 is 0. So again, we've got these normal numbers, if you like, on the top, and the logarithm now in base 2 on the bottom. 2 to the power 1 is 2, and so the exponent here is 1, logarithm is 1. 2 to the power 2, logarithm is 2, 2 times 2, 2 squared, that gives us 4. 2 to the power 3, or 8, the logarithm is 3, that's the exponent. But now, what happens if 2 to the power minus 1, so that's 1 over 2, or 0.5. So here the logarithm in base 2 is minus 1. 2 to the power minus 2, so that gives us 1 over 2 to the power 2, or 1 over 4, or 0.25. So the exponent is minus 2, logarithm in base 2 is minus 2. And then we look at 2 to the minus 3, that's 1 over 8, or 0.125, and the logarithm in base 2 is minus 3. So here the range of the logs is much smaller. We're going from 0.125 to 8. So we get a much smaller range with our logarithms. So that might be a reason to use one or the other.